Hello guys and welcome back to my channel Interview with Bunny, and today we are back with another video on system designing playlist. And the video or the topic that we will be designing today for the system designing interview is none other than the social media platforms such as Facebook or Instagram. So this is considered as one of the most important question on the system designing interview because this is one of the most commonly asked question during your system design. So without wasting much time, let's get started with today's video of designing the social media platforms such as Facebook or Instagram. So since you guys are already familiar with all the functionalities and the behavior of how a social media platform actually works, so we won't be wasting too much time in understanding the platform. Rather, what we will do, we will start with the first step of our designing, and that is the gathering of the functional requirement. So the functional requirement of the social media platform is quite simple and straightforward. The first one is that user should be able to log in and do the sign up and the signing process, means the onboarding process for the user. Number two, user should be able to create and share post in the form of the textual form as well as in the form of the image. So since here we are considering a generalized social media platform, so we will take into consideration both the image as well as the text, means the supported documents are the text, image or a video. Number three, users should be able to send requests or follow each other. So in case of the Instagram, as you know, user will be able to follow each other. But in case of the Facebook, there you have the option of both following as well as sending the friend request. So here, just to make it simple, we will only implement the feature of following each other. Number four, users should be able to like or comment on the post. And the last but not the least, and probably one of the most important functional requirement that we will be solving here, that is user should be able to see the feed of all the user that he follows. So for example, as a user, I follow 10%. So all the posts or most of the posts that are most important or relevant to me should come up in my display as a feed. So these are more or less all the 5 major core functional requirements that we will try to solve in this problem. But remember, there are few of the other functionality that we will keep it out of scope. For example, the user won't have the functionality of adding a story or something like that. Number two, user won't able to upload a reel or something. And the next one is there won't be any messaging service or a chat based application over here. Because as you know, the chat application or the messenger service is altogether a different system designing problem that needs an in-depth knowledge, which I have already solved it in the 8th video of the channel. So this will be totally out of scope for this video. So let me list down all the functional requirements that we are trying to solve in this video. So here you can see these are all the 5 functional requirements that we will be solving. Clear? Now let's move to the next part, and that is the gathering of the non-functional requirement. And the first non-functional requirement that we will consider over here is the scale of the system. And when you will be asking your interviewer that what is the scale of the system that you will be targeting over here, he will be telling you that the scale of this application or the scale of this social media platform will be a huge one. That is around 500 million daily active users. So the scale of the system will be 500 million daily active user. Clear? Now the next non-functional requirement that is one of the most important thing, and that is the cap theorem. And as you know, the cap theorem tells that whenever you are creating a distributed architecture, you have to either compromise between the high consistency or high availability. Means a particular module of the system cannot be highly consistent as well as highly available at the same time. And here as you see, since the scale of the system is quite huge, so obviously this application should be a distributed system, means it should be a microservice based architecture. And since it is a distributed system, so we have to consider that whether our system should be highly consistent or it should be highly available. And if you just look into our system, you will get to know that our system should be highly available rather than consistent, because it is not required that as soon as I share a post or share an image on the social media platform, it is not required that on the 0th second that post should reach all my friends or followers who actually follows me. It is completely fine that after a minute or so, or maybe after an hour, that post is visible to my follower. So our system can be eventual consistent, but it should be highly available, because it is very bad experience for the user that once you open our Facebook application and the application is down for some time. So here you can easily understand that our application should be highly available rather than highly consistent. So based on the CAP theorem, we will give the priority to the availability rather than the consistency. Means our application should be eventual consistent. And the next non-functional requirement that we have to discuss with our interviewer is the latency of the system. And whenever I'm talking about the latency of the system, I mean that uploading speed of the post. Means whenever I publish something on the social media platform, it should get uploaded as soon as possible based on our internet speed. So here what we will consider for an average for a text or an image, the latency to upload a post on the social media platform will be around 500 milliseconds. So these are more or less all the major functional and the non-functional requirements that we will be solving over here. So since we have gathered or since we have already solved the first step of our problem, let's now go to the next step of solving this problem, and that is the identification of the core entity. And here if you look carefully or if you go through the functional requirement carefully, you will easily get an idea of what are the major core entities that we can point out over here. So the first and the primary core entity will be the user who will be actually logging or using our application. Number 2 is the social media post. Number 3, the friends or the followers who will be following each other. Number 4, the like and the comment means the interaction with each other. And the last but not the least, the feed of our application means whatever the content you see once you open your application. So these are more or less all the primary core entities that we can identify as of now. So it might can happen that once you create our application in complete detail, there you can find out some other core entities in our application. But as of now, just by reading this functional requirement that we have gathered from our interviewer, these are all the 5 most important core entities that we can identify as of now. So let me list down all those things over here. Now let's move to the third step of our designing, and that is the API designing. And as you know, creating the API endpoints are actually quite easy if you have gathered the functional requirement correctly, because in most of the time API designing have one-to-many relationship with each and every functional requirement that we have collected. So let's see what are the major API endpoints that we need to solve all the functional requirement that we have gathered. So here if you look carefully, there are some major functionality that we have to support over here. The first one is the onboarding process. So let's first identify that what are the major endpoints that you need to onboard all the user into our application. So what I will do, I will list down all the API endpoints that we need for the user onboarding. After that, I will explain you in detail that what each and everything will do so that we can save some time over here. So few of the most important endpoints that we need for the user onboarding process is number 1, the registration, number 2, the login, number 3, getting the metadata of the user, and number 4, the updating the metadata. So here if you see, this is the first endpoint, that is the register endpoint, where you are submitting the information about your name, where you are located and all those things in our application. And since you are submitting something in our database, so obviously this should be a post endpoint. Number 2 is the login, where you are submitting your credential and we will give the user the permission to use the application. So this will be our second endpoint. Number 3, the endpoint that is required to retrieve the information of a particular user. So for example, as you see, once I land to a particular user, for example here when I open my user profile, here you can see all the metadata of my profile, means what is the intro on my channel, where I have already worked on, and all the information that are relevant to my profile. So this will be our third endpoint, that will be a get endpoint, since you are getting the information from our application. And the last is the put endpoint, means we are giving the user the functionality to edit or update the profile metadata. And that is why, since it is an edit operation, so here it will be a put request. I hope this is clear that what are the major endpoints that we need for a user onboarding process. So here if you look carefully, there can be some other endpoints also that is required to update the user profile. So for example, user want to change the cover picture or the user want to update the profile picture. So all those things we are not considering as of now. Here we are going with some of the basic requirement that we have to solve over here, because otherwise you have to keep on listing all the endpoints that are required for each and every feature, which will take a lot of time. And as you know, during your interview you do not have that much amount of time to solve all the features. So discuss with your interviewer at the very beginning that what are the major core functionality that he wants you to solve. And as you can see here, we have just taken into consideration that we will give the user the provision to register and log in. So here we are just considering only these 4 endpoints that will solve all our purpose. Clear? Now let's go to the next functionality of our application that we have to solve, and that is the creation of the post. Means we have to provide all the endpoints that are relevant to submit a post in our application. So here also let me list down all those endpoints over here. So these are all the endpoints or the REST endpoint that we need to support the functionality of post. So the first one is to create a post, and here you can see the method is post. Since you are uploading something in our application, so obviously it will be a post method. Number 2 is the get. Means for example, you have uploaded an image, so you need to see the image as well as you have to check all the metadata. Means what is the description of the post, how many users have liked that post, what are the comments and everything. So for that we have the second endpoint, that is the get endpoint. Number 3, we have given the provision to edit a particular post. Number 4 is the delete operation. That is quite straightforward. The next one is another most important, and that is the feed of a user. So for example, once I log into our application or log into a social media platform, we can see all the relevant posts of all the friends whom I follow. So here this will be the API endpoints, that is the get API endpoint that we need to retrieve all the information. And as you can see here, we are getting the information in the form of the pagination, because as you know, a particular user can have thousands and thousands of friends on the social media, and for those thousands of friends we can have lakhs of posts at a particular time. So here, instead of fetching all those lakhs of information in our front end, what we will do, we will give the information in the form of the pagination. Means for example, at a particular time when you open the application, you can see 30 to 50 posts at a particular time. Once you are done with scrolling all these 50 posts, another call will go over here to fetch the next 50 or next 100 relevant posts. So in this way, all this information will be coming in the form of the pagination. I hope this is clear that how we will be solving this problem. And remember, this is one of the crucial and the major functionality of this social media platform, because in our entire system designing video, this is the most important functional requirement that we will be solving going forward. Now the next one is getting all the posts based on the user ID, which means that for example, I open a particular profile or I want to check all the list of posts that a particular user have. So based on the user ID, it will retrieve all the posts for a particular user, and also this should also be in the form of the pagination, because it is quite obvious that if a user is using our application for a long time, there will be thousands and thousands of posts in his profile. So obviously we should not retrieve all those heavy information on a single go. Rather, we will be retrieving in the form of the pagination, so that the loading time of our application decreases significantly. I hope this is clear that why we are fetching all this information in the form of the pagination. Now let's go to the next important functional requirement, and that is the interaction between the user. Means here if you see, we have the next functional requirement that we have to solve, that is like and comment as well as the following each other. So this is nothing but the interaction among each other. So here we will be having our next set of API endpoints that we need to fulfill all the interaction that we are doing in the social media. So let me list down all those things over here. So these are all the endpoints that we need to fulfill the functionality of interaction between the user. That is, here you can see we have the like, unlike. After that, we have the provision to view all the comments for a particular post. Similarly, we have the functionality for follow and unfollow. So here you can see we have solved, or we have found out all the endpoints or the REST endpoints that we need to fulfill all the functional requirement that we have gathered. So here you can see this is quite straightforward and simple. And as I was telling you, in most of the cases, API endpoint have one-to-many relationship with the functional requirements. So here you can see for solving the first requirement, that is register or login into our application, we have used 4 endpoints to solve this functional requirement. So since here we are done with the 3 steps of our designing, that is the gathering of the function and the non-functional requirement, number 2, the identification of the core entity, and number 3, the API designing, let's now go to the next step and one of the important steps of our system designing, and that is the high-level designing of our application, where we will see that what are the major services that we need in our application to fulfill all the functional requirements that we have gathered. So let's move to our fourth step, and that is the high-level designing of our application. So let's start with the high-level design. So the first thing that we need is the user in our high-level design. So what we will do, here we will first draw few of the user or the clients who will be using our application. So this can be a mobile client or it can be from a web browser. So this will be our users or the clients. Now the next thing that we need is the load balancer. So as I was discussing during our non-functional requirement, this application will be used by a huge amount of users, which is around 500 daily active users. And obviously since the number of users is quite huge, so here we have to go with the microservice architecture. And whenever we are dealing with a microservice or a distributed architecture, obviously we need a load balancer and an API gateway to route our traffic uniformly across all our backend services. So what I will do here, I will draw our first service, and that is our API gateway and a load balancer. And as you know, the responsibility or the role of the load balancer and the API gateway are nothing but authentication and authorization, rate limiting and routing. And obviously here, since we are using our load balancer, so the way the traffic will be distributed across all the backend service is with the help of the round robin approach. I hope this is quite simple and straightforward. This is the same structure we are using across all our videos. So here we are done with the two components, that is the user one and the load balancer. Now let's start with the first module or the first component that is required for our designing, and that is the user onboarding service. And for that, what we will do, here we will draw our first component, and that is the user service. And the responsibility of this user service is primarily the user onboarding. Means whenever the user registers into our application, what it actually does, with the help of these APIs that we have defined over here, it will save that information of the user in our database. So to persist that information, we need a database over here called as a user database. Clear? So here we will be having our first database or the first table in our application, and that is the user table. So the flow is like the request will first come into our load balancer or into our API gateway, and based on the URL or the API endpoint, the API gateway will route the traffic to the user service, and from the user service the data will get persisted in the user DB. Clear? So here I will just complete this flow, and that's it. Here everything is done based on the user onboarding. And as you know, since this is the high level designing, we will only see what are the major components that are required to fulfill all our functional requirements. We will go in detail that how the user service will work, or what is the database, or how the schema structure of this user DB will look like in our next section, that is in the low level or the deep dive section, where we will discuss in detail of each and every component that we will be discussing. So let's go to the next thing, and the next functional requirement, that is the user should be able to create post into our application. And for that, for creating a post in our application, what we need a service that will help the user to post something in our backend. Means it can be a video, it can be an image, or it can be a textual form. So here what we will do, here we will create another service called as the content service, which will handle all type of content in our application. So this will be our second service called as the content service. And as I was telling you, this content service will persist all the information of the content in the backend. And there can be two major type of content. One is the video or the image file, and another is the metadata or the textual form of the content. For example, you want to post a status in your Facebook, so that will be a textual form of the content. And whenever it is a textual form, what we will do, here we will introduce a database called as a post DB. Means all the textual form of the post will get persisted over here. But whenever a user want to persist any image or the media file, then what we will do, here instead of saving it in our database, what we do, we normally save it in a blob storage. That is, here we will be having a blob storage or a S3 bucket to persist all the media files over here. So from this content service, there will be two arrows, one to the post database to save all the metadata or the textual form of the content, and another arrow will go to the S3 bucket or the blob storage, where we will save the actual video or the images, that is a huge file in our S3 bucket. Clear? So the request will come into our content service, and from there it will get persisted accordingly. Now let's go to the next function, and probably one of the most critical function of our application, that is the feed service. Means whenever a user opens the application, obviously there will be some content that we will show to each and every user based on the follower list or the type of content he likes to see. So here what we will have, here we will be having our next service, that is the feed service. So what will happen once the user opens the application, a request will come to our feed service, and from there we will generate a feed for that particular user based on the followers or the friend list he have. So what we need, here we need to connect with two databases. One is with the post database and another is the friend or the follower database, from which we can get the list of followers or the friends he interacts the most. So what will happen, there will be two arrows, one directing from the feed service to this post database over here, and another request will go to the follower or the friends DB. But before that, what we need to complete one more service, that is the friend or the follower service. So here we will be having one more service called as the follower service. So for the Instagram, you can call it as a follower service. For the Facebook, we can call it as a friend service. So whatever you say, the functionality will be more or less the same. So here, to persist the information of the friends or the follower, we need another database to persist, that is called as the follower DB. Now what happens is, like, whenever a user opens our application, the request will go into our feed service. So first request will go to this follower database, and based on that we will retrieve all the followers that a particular user have. And after that, once we get a list of followers that a user follows, then what we will do, we will make another API call to this post database to see what are the posts those followers have already posted, and based on that we will make an inner join or something, and thereafter we will retrieve all that information into our feed service and we will display it to the user in the front end. Clear? So this is how the flow will look like as of now when we are designing the high level designing. But believe me, this is not at all simple the way I am telling you right now. But just to get an idea that how the service will interact, just get an understanding that this is how the service will interact between each other. Now let's go to the next service, and probably one of the easiest service, and that is this like, follow and comment. So for that, what we will do, we will create a single service that we will be calling as the engagement service, which will be responsible to collect like, comments and all this metadata that is required to interact between each other. So here we will be having our fifth service called as the engagement service. And thus this engagement service will do two things. Number one, it will save the information of like, and number two, the comments that we got for each and every post. So here we will be having two databases. One is the comment database and another will be a like database. So let me just create it quickly so that it will be easy for you to understand. So here we are having the two databases, that is the like and the comment. And here if you see, we are using only a single service that is called an engagement service to perform both the operation. But obviously in the real life, it will be a separate services that will be interacting with each and every database, and it will be responsible to collect all this information. But all those things we will see in detail in our next section, that is the fifth step of our designing, that is the deep dive analysis or the low level designing of a system, where we will go inside of each and every component and we will see in detail that how they will interact with each other, what are the additional components that are required to facilitate or to enhance the performance of the services, and everything that is required to fulfill all the functional as well as the non-functional requirement to solve this problem. But as of now, here you can see this is more or less all the necessary or the primary components that are required to fulfill all the functional requirements that we have collected so far. So without wasting much time, let's go to the last and the final step of our designing, and that is the deep dive analysis or the low level designing of our system. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So let's start with the low level or the deep dive designing of this system. So the first thing what I will do, I will copy this entire high level designing from here and I will paste it in our low level section so that we can enhance it further. So the first component that we will enhance is the user service. And as you know, the user service is quite simple. That is, the main responsibility of this service is the user onboarding. So when a user comes to our application, it registers all the metadata of the user, such as name, user ID, email ID, and all those things. And in the future, when the user try to authenticate onto our application, means try to log in into our application, this user service will be also responsible for the login purpose, means the user authentication. And if there is a match in the credential, what we will do, we will return the JWT token in the response so that the user can access all our internal services accordingly. So as you can see, the user service is quite simple. Let's see what will be the schema structure and what type of database we will be using over here. So since user metadata is only a straightforward flat metadata, so what we will do, we will use a simple Postgres or a MySQL solution. So here what I will do, I will go with the Postgres solution so that it will be easy for us to scale in the future. So let's see how the schema structure will look like. So these are all the metadata that we will be storing over here. That is the user ID, username, email, password, phone number, and all those metadata. So there can be further more metadata that you can save in your database. So that is totally your choice. But based on the requirement that we have gathered, these are the minimum amount of metadata that we need to persist in our database. So this will be our Postgres database and this will be the schema structure of our user DB. I hope this is quite clear and straightforward. Now let's go to the next service, and that is the content service. Means once the user uploads something in our application, then how we will handle or store that metadata. So here as you see in our high level designing, what we did, we were using a simple structure. That is, all the content will come into our content service and from there we will save all the textual data into the post database and all the media file in the S3 bucket. But actually in the real world, this is not at all simple like this. Because as you know, there will be millions and millions of content that will get uploaded each and every second within the Facebook or within Instagram. So by this architecture, it is not possible to handle that amount of load in our system. So let's see how we can enhance this structure so that we can create our system much more resilient and scalable. So what I will do, first I will get rid of all these things. And what will happen is like, here once the user uploads something in our backend services, the first thing that will happen, we will try to store that information or we will try to persist that information in a temporary buffer. And for that what we will do, we need a streaming platform or we need a broker over here, and for that we will need a Kafka broker over here. So here what I will introduce a Kafka broker. And within this Kafka broker, there will be multiple topics that we need over here. So let's see what are the topics or what are the services that we need within this Kafka broker to persist and process the data. So first thing that we need over here is like, so for example, a user uploads some data in our application. So the data will get persisted within the Kafka broker in a topic called as a raw post. So here we will be having our first topic called as the raw post. Clear? Now the next step is like, obviously once a user is uploading something, it is the responsibility of the social media platform to validate the content, because the content can be anything. It can be a malicious content, it can be a vulgar content. So we have to get rid of all this content that are not supported by our policy. So for that, to filter out those raw posts, what we need, here we need a moderator service, and the responsibility of this is to sanitize the data. So here we will be having our first service to filter out all the raw posts. That is, here we will be having our moderator service. I hope this is clear that why we are using a moderator service to filter out the raw content. And what we will do, basically this is a consumer service. It will pull out all the data from this raw post, and based on some AI ML model or something, we have to sanitize the data. Means here once we read the data, we have to classify each and every post into two things. One is the filtered post, means the post is a valid one and it can go in the social media, and the next one is an unfiltered post or the block content that we cannot publish in our platform. So here we will be having further two topics within the Kafka. Number one is the filtered post and the next is the block post. I hope this is clear. Now once the post reach our filtered post topic, means this content is valid one. So what we need, here we need another service called as a consumer service, which will actually drive the data from this Kafka into our database so that we can publish it for the users. So what we will do, here we will be having our next service called as a post consumer service. And this post consumer service will do two things. Number one, if the data or if the content is a textual one, then it will persist it in our post database. And if the data is a media file, then it will persist in the S3 bucket. Clear? So we will draw that accordingly. I hope this is clear. This is what the post consumer service is doing over here. Now let's see what will be the schema structure of the post database and what can be the database that we will be using over here. So this will be the schema structure of the post database. So here we have the post ID, the user ID who is doing the post. Number 3, the post type means whether it's a media file or a video file. Then the content text means the description, or if it is only a textual form, then it will go in the content text. Then we have the media URL, means whether it's an image or the video file. Then we have the thumbnail, means if it is a video, we need a picture or a thumbnail that is on a lower resolution. So that is why here we need a thumbnail URL. Then we have the like count, share count, comment count, and all those other metadata. So just to give you an idea, though here I am telling you we are supporting both the image file as well as the video file, but we are not showing that how the video files are getting uploaded, because that is again a big thing on the respect to system designing, because all those videos should get uploaded in our system in the form of the chunks and bit. Because if you remember, I have already covered all these things in my OTT platform where I have shown you in detail that how a video file that are huge size, means the media file, gets uploaded in the backend. Here you can see we have the video metadata, the chunker service, and all these things, that how we are encoding the video and how all these things actually works. So basically the video uploading service actually follow the same architecture that we have discussed in our OTT platform. So feel free to go through that video first if you need to know that how a video file or how an image file gets uploaded in the backend. So just to make it simplified over here, we are not discussing it over here. Just we are mentioning it that the post type will be a video or an image, and there will be some service who will handle all this uploading service. Clear? Now, the database that we will be selecting over here will be a Cassandra one, because of the fact here, if you understand, there will be thousands of requests for the post submission in our backend, and to handle that amount of load, we need a database that is write efficient. Means the latency to write in the database should be as nominal as possible, and the database that support it is nothing but the Cassandra database. And that is why here we are choosing a Cassandra database to save all the metadata of the post and all the information of the post. So this is how the schema structure will look like. I hope this is clear till now. Now there is one more flow, that is, for example, you have uploaded something that violates the policy of the Facebook or Instagram. Then what will happen? Based on this moderator service, your post cannot be posted in our social media, so it will move to our topic, that is the blog post. And once it gets uploaded to the blog post, we have to notify the user that your post got blocked by the social media. So what we will do, here we will be having another service that is nothing but a notifier service, which will tell the user that your post that you have uploaded got blocked by our policy. So here we will be having another service called as a notification service. I hope this is clear that how someone is uploading data or post in the social media. So the file or the data is first coming to our content service. From there, it is going to our Kafka broker, and once it reaches the Kafka broker, our moderator service is first checking the validity of the data, and if it is a valid data, it will go into our filtered post topic, and from there, it will get consumed by our post consumer service, and it will get ingested in our database. And otherwise, what will happen, it will go into our blog post, and thereafter it will get notified to the user with the help of the notification service. Clear? Here, if you want to add, you can add one more service, or you can enhance this post service also, so that all the data that got blocked into our system also persists in the database, so that we can validate it in the future, or we can learn something with the help of some AI model. So that is totally out of scope right now. So here we are done with the two of the services, that is the user service and the content service. I hope this is clear till now. Now before going into our feed service, what we will do, we will complete two other services, that is the follower and the engagement service. Because believe me, this will be a huge thing to implement, and there are a lot of other dependencies on these services also to implement this feed service. So that is why what I will do, I will first implement this follower service and the engagement service, and thereafter I will move to our feed service. So our follower service or our friend service, whatever you call, perform the same activity. Means it just stores the relationship between the user, means who is the friend of which user and who follows whom. So that is the main responsibility of this follower service, which is actually quite a straightforward solution. Only thing we need to discuss over here is that what will be the schema structure of this follower DB. So let's see what will be the schema structure and what type of DB we will be using over here. So this is how the schema structure of the follower DB will look like. So here we are having a follow ID, which is an auto-generated ID, which can be a UID over here. Then we are having a follower ID, means who is following. After that, we are having the following ID, then status and the timestamp. The only difference between the follower ID and the following ID is like, this is nothing but the user ID who is actually following someone. Means for example, I follow 5 people. So here the follower ID will be the my ID. And for example, here I am following 5 different users. So all those friends ID will be part of this following ID. I hope this is clear that what is the difference between the follower ID and the following ID. So there can be one-to-N relationship over here. So a particular user ID can follow multiple users across the platform. And that is why here we need a unique key, which is nothing but a follow ID, which will be a auto-generated ID. I hope this is clear. And here you can see I have given a status. So for example, in case of the Facebook, there we can have the pending status to accept the friend request or so. So that's why here I have given an attribute called as status. After that, we have the timestamp, is when you have sent the friend request or the follow request and all those things. So this is how the schema structure will look like. Now, if you see here, to implement this follower DB, here I am using a simple Postgres relational database, not any complex database such as a graph DB. Because of the fact, here what we are saving, we are just saving the relationship between the follower and the following. Here we are not solving anything complex, so we do not have to save all those metadata in a graph DB. Only thing, if your interviewer asks you that you have to implement something extra on this feature, for example, you have to create a suggestion list of the friends where we can see who is the friends of friends and all these things, there only use a graph database. Otherwise, just to persist the relationship between the follower and the following, this Postgres database is enough. I hope this is clear that why here we are using a Postgres database rather than a graph DB. So this is how the schema structure of the follower database will look like. So here we are done with our follower service. Now the next one is the engagement service, means with the help of which all the likes and the comments will get persisted in our backend. So here, as you know, at a particular instance on a Facebook, there can be millions of the like and the comment requests that will go in the backend. And with that amount of threshold on the request, it is impossible for a particular server to handle. Whatever may be the replication factor we implement over here, it is impossible for a server to handle that amount of load. So whenever there is any problem like this, means the amount of the data that is coming is tremendous, there simply use a pops up technique. Means here, before this thing get ingested in our database, what we will do, here we will introduce a Kafka broker so that we can take all this request or all this like comment in the buffer. So here what I will do, here I will introduce a Kafka broker over here. And another great advantage of using a Kafka over here is like we are ensuring that whatever the user is doing in the front end, we will not lose any of the event over here, because Kafka ensures guaranteed delivery in the system. Means whatever the data that comes to the Kafka will get ingested at least once by your engagement or by your consumer service. So here what is happening, whatever interaction you are getting in your application, it will first come into our Kafka broker, and from there here we will be having our engagement service, which will consume all the likes and comments from our Kafka broker, and it will simply register everything in our database. So here you can easily have two services, one for the comment and another for the like and the share. So just to make it simple, I am just introducing only one service, that is the engagement service. I hope this is clear that how the functionality is working over here. Now let's see what will be the schema structure or what type of database we will be using over here for the comment and for the like. So this is how the schema structure of the comment and the like database will look like. So here we are having the comment ID, the post ID, the user who is doing the comment, the like count and all the other metadata. So here if you see, the like count is nothing but the aggregated form of the like. Means for a particular comment there can be thousands and thousands of like. So the aggregated form of the like will get persisted in the like count. But in case of the like database, here we are using a Postgres database, and here we are having the like ID, which is an auto increment ID. Thereafter we are having the post ID and the comment ID. Means for example, a like can be for a post or for a comment. So based on that you will give the ID over here. After that, who is liking that comment or the post, so here we are having the user ID for that, and thereafter we are having the reaction type. Means whether it's a heart, like or whatever it can be, we are saving it like this. I hope this is clear. And what type of database this comment will be? This can be again a Cassandra database, because this is obviously will be a write heavy database. So here also we are using a Cassandra database to save all the comments of the post. I hope this is clear. And obviously there should be some service that will aggregate all the like from here and will persist it in our comment database. So you have to create it accordingly. I am not going into the detail of all these things. So if your interviewer is asking for that, just simply add another service over here so that that service can aggregate all the like from here and it can persist it again in our comment database. I hope this is clear that how these two services, that is the follower service and the like service or the engagement service, will work over here. Now let's go to the one of the most important service of our social media platform, and that is the feed service. And let's see how this feed service will actually work and how we will implement it. Now, before going into the feed service, we need to know two things. That is, whatever we discuss over here, the way we will be generating the feed with the help of the inner join also is actually not possible in the real life. Because if you understand this concept clearly, for example, I have thousands of friends in my social media. And now if I open my social media, what will happen is like this feed service will first try to fetch all those followers from the database. And let's take an example. I have 10,000 friends in the social media. Then what will happen? It will first fetch all the 10,000 friends from this database, and thereafter it have to go to this post database, means to see that for each and every friend, whatever the content that is present in the post database. And based on that, there will be an inner join between the friends and the post that the friend have done. And based on that inner join, we have to give the response to the user. And believe me, that will take a hell lot of time, and your front end will definitely hang for an indefinite amount of time. So that is actually not a feasible solution to implement in a large scale. So what we have to do, we have to pre-compute something. Means before I log in into our application, whatever should get delivered to my front end, is whatever the feed should come into my front end should get pre-computed for me. Otherwise, if we do this computation or calculation of what will be the feed of a particular person at the runtime, then it is not a feasible solution. So let's see how this feed generation or this feed service will work. So the popular method by which this feed actually works in the social media or any news platform is with the help of the fan-out model. So let's first understand that what is a fan-out model. So a fan-out model is nothing but a design pattern by which the feed of the social media actually gets generated. And there are two ways by which you can generate a fan-out. One is the pull model and another is the push model. Let's see what is the difference between the push model and the pull model. So for example, what happens is like, for example, you are a small user of the social media, means you do not have that much amount of the followers on the social media. So at that time, we use the push model. So for example, I am a user on the social media and I have only a limited number of friends or the followers. So what will happen at that time, once I post something on the social media, all their feeds will get updated with my latest post. So that once the second user, who is nothing but my friend, opens the Facebook account, there immediately he gets the content that I have already posted on the social media platform. So his feed is already generated with the latest post that I have already delivered. And there is one more service, that is the pull model, which is applicable for the celebrities who have millions of followers in the social media. Now, why there is a difference between this push model and the pull model? I will tell you just now. So here, let's take an example. Here I am the user and I have 1,000 friends. Clear? Now there is one more user who is actually nothing but a celebrity and he have a millions of followers now. For example, I am uploading something in the social media. Then what will happen? Based on this feed generation logic, once I post something on the social media, all the feeds of this 1,000 user will get updated accordingly. But in case of a celebrity, if we try to do the same thing, there will be a serious problem. That is, here once he posts something, we have to do a millions of operations to update millions of users who are actually following him. So here you can see, since there will be a lot of operations that we have to do in case of a celebrity, that is why here we are not using a push method. Rather, what we are doing, we are using a pull method. Means once the user requests for the data from the celebrity, then only the data will come into his feed. I hope you got a simple overview how this fan out model will actually work. So this is just a heads up. Once I will implement this entire thing, it will be damn easy for you to understand. So I will just put this thing aside. Now with this assumption that you got some idea about how the feed service will work, is how the fan out mechanism actually works, let's start with implementing this feed service. So as I was telling you, what actually happens, once a user comes to our application, the feed is already prepared for that user. And as I'm telling it that it is already prepared, means it should be coming from a database or coming from a storage unit. So here what will happen, this feed service will talk to a feed database. So here we need another database called as a feed database, where all the pre-computed feeds will already persist in the database. So here we have resolved one of the problem, that is here we are not generating the feed of the user on runtime because this is already pre-computed and it is already there in the server. But there is one problem, that is accessing a database is actually a time consuming activity, and to reduce that, what we need here, instead of directly interacting with the database, we need a cache before that. So instead of hitting the feed database, here we need another service that is nothing but a feed cache. I hope this is clear. So all the read activities are going from the feed service to the feed cache. Means once the user comes to our application, the feed service fetches the data from the feed cache and it just show it to the user. Now the main thing is like how the data comes into this feed DB. What is the technique or how we generate the feed from the user? So the way we actually generate the user feed is with the help of the Fanout service that we were discussing just before this. So what will happen here, once the user posting something with the help of this content service, there will be one more service that will interact over here in the Kafka broker, and that is nothing but this Fanout service which will follow the push model. So let me just introduce this service. So here we are having the Fanout service. So what happens is like, for example, I am posting something on the social media, and once this moderator service validates that post, it will come into our filtered post. And once it comes on the filtered post, two things are happening. Number one, the post consumer service is consuming that in our database, and another service that is there is nothing but the Fanout service, which also consume this data. And what it does, if you are not a celebrity at that time only, this service get activated. And what happens is like, it update the feeds of all the friends that you have. So here what we need, we have to first check that what are the friends for a particular user. And for that, what we need, here we have to interact with this follower DB. Means, for example, I am uploading something. At that time, what will happen? This Fanout service will check that what are the friends who follows me, and based on that, since I'm not a celebrity, it will ingest that data or ingest that post. So what will happen? It will first fetch all the friends that I have, and based on that, it will again put it in a Kafka broker. So what is happening? This Fanout service, once the post is uploaded by me, it will first check what are the friends I have, and based on that, it will create an entry in this Kafka broker. Means for this post which I have uploaded, these are all the user ID on which the cache or the feeds have to be uploaded, and based on that, it will keep an entry over here in the Kafka. And once this entry is there in the Kafka, we know that for a particular post that I have, all the feeds of these users should get updated. So here what will happen, there will be one more service called as a Fanout consumer service. And this Fanout consumer will be actually responsible for creating the feeds for all the users. So what will happen, based on the post ID and the user ID, it will first check that what is the actual post that is present over here. So it will get all the metadata from here, and thereafter it will ingest that data in the feed DB as well as the feed cache of all the friends who are actually following me. Clear? So this is how the thing will work over here. So this will be a write request to update the feed service. Similarly, this will be also a write request to update the cache over here. So once I'm uploading something on the social media, what is happening? This Fanout service is first checking that who are my followers, and based on that, it is just making an entry in the Kafka that for this particular post, this post should go the feed of this user ID who are nothing but his friends. And based on this entry, this Fanout service will consume that entry, and it will get the post from our post database, and thereafter it will update both the database as well as the feed cache, so that once the second user, means who is nothing but my friend, comes to our application, that user can get a prepared feed from this feed cache. I hope this is clear that how this things is actually working over here. But there is still a problem. There is obviously a limitation of the feed cache. Here we cannot save all the data that all the user are uploading. So here what we have to do, here we have to limit the amounts of feed for a particular user. So for example, for a user, before he logs in to our application, we can only save a 50 to 100 feeds for a user, so that there is a bound on the size of the data that we are saving in the feed. So obviously there should be a TTL on whatever the entry that are going in the feed. Clear? Now there is one problem. That is, for example, my friends come into our social media. He have already consumed all the 50 posts that were already prepared within the feed service. So now what we have to do? We have to prepare a feed for him. So again we have came into the problem that we have to compute the feed in the real time. So to solve that problem, again we have to find out some solution. And how we perform that? We can perform it with a backfilling process. That is, here once we identify from the front end that the user who is scrolling into our application is done with 50 or 100 feeds that are already pre-computed, we make another backend API call to generate the latest feed for him, so that the user gets a feature of an infinite scrolling. So what will happen, that once our service get to know that the user is about to complete all the feeds that are pre-computed, another call will go into another service That is nothing but a backfill service. Means you have to generate the latest feed for this user. So here we will be having our next service called the backfill service. And what is the responsibility of this backfill service? It have to generate all the feeds in near real time. And as you already know, it is quite impossible to generate all the feeds in the near real time. So we have to find out some solution to this problem. So what actually happens is, like here also, to run the backfill process, we take the help of some pre-computed data. Let's see what are the pre-computed data we store in our backend. So what happens is, like there is another flow that gets triggered when you upload something in the social media. That is over here. So here we will introduce one more service called as a post materializer. So let me just draw it over here. After that, I will let you know what this service actually does and what is the significance of this service and how it will help in the backfilling process. So this post materializer service will do a single thing. That is, it will read the data from the Kafka which are already in the filtered post. And from here, what it will do, it will persist a very important data. That is, it will persist all the recent activities of the user. So for example, I am posting something on the social media. So it will persist all my recent activities in a database, or it will save it in a cache. So here what will happen? There will be a Redis cache over here. So let me just draw it over here. So here we are having the Redis cache, and this Redis cache will save all the recent activities or whatever the post I have posted on the social media. This, for example, all my 100 latest posts. So here you can see this post materializer serving is saving an important thing. That is, what are the latest activities or the posts that particular user is submitting in our social media. So all those information are present pre-computed within this Redis cache. Now, why this is important, you will get to know very soon. So here, if you understand or look carefully, you will get to know this backfill service have to compute everything in the near real time. Means it have to check that what are the followers or the friends I follow, and based on that it have to fetch all the latest posts of that user. So to implement that only, here we are using this approach. So what it will do, this backfill service will first fetch all my friend list from this database, means the follower database. And once it fetches all the user ID or the friend list that I follows, what it will do? It will simply try to get all the latest posts of those friends from this Redis cluster. So here if you see, we are handling this scenario quite intelligently. Here, instead of going into this database, means the post database, to scan all the data of the user, here with the help of the Redis cache, we are getting all the pre-computed latest data from the Redis cache. I hope this is clear. So all the user ID we are getting from this follower DB, and based on that it is simply a fetch call to this Redis cache to get all the latest posts of the user. And since here we are saving 100 posts per user, so you can see that we can easily generate the feed of a particular user quite easily in the near real time, because everything is pre-computed over here and we do not have to go to the database to fetch all this information. And thus, once we get all this information, means all the list of the friends and as well as all the posts that we have to deliver to the user, what will happen? We will save all this information into this Kafka broker. Means right now what we have the information of the user for which the new feed will get generated and all the list of the posts that we have to display to that user. So let's see what we will submit in the Kafka broker. So here you can see this backfill process is writing in the Kafka broker, and what it is writing, that is the user ID and the list of posts that we have to update in the feed. Means for this particular user, these are the posts that need to be updated in the feed. And who does this activity? That is nothing but this Fanout service. Means once this mapping is there for this Fanout service, it can easily update all the feed cache of the user. I hope this is clear that how this backfilling process is actually working over here. And in the similar way also, same thing happens from the celebrity. Means once the celebrity uploads something, here at that time we do not update this feed service. What we do, with the help of this backfilling process, we intelligently put all the posts of the celebrity in the cache with this backfill process. I hope this is clear that how this entire thing is happening. But there is still some more enhancement that you can do over here. That is, if you look carefully on our social media, at a particular instance or after you use the application for a few days, we will get to know one behavior. That is, though we have thousands and thousands of friends in our social media, we do not see all the feeds of those hundred or thousands of users. Rather, we only see the feeds of 100 or 200 posts which we interact the most, which we follow the most. And to implement that feature, we need to do one more thing. That is, what we are doing over here, if you look carefully, we are getting all the list of followers directly from this follower DB. And what it will return? Obviously, it will return all the list of followers that we have. It can be thousands and thousands over here for a particular user. But actually generating the feeds of 100 friends or so, we actually do not need all this information. So to optimize that even further, what we can do, here we can place another cache over here who are nothing but the user whom we follow the most. So let me just enhance this model a bit more so that it will be easy for you. After that, I will explain you how this flow will work. So here, if you look carefully what I did, here instead of directly interacting with the database, here we have introduced one more level of cache. That is a follower cache where we have the information of only the top follower within our friend list. So for example, I follow thousands of people in the social media, but at a particular instance, I am interested only to see, or my social media is populated with only the feeds of those whom I interact the most or who are the top celebrity. So here in this cache, we are actually saving that information. Means here we are saving the top followers in my social media. And obviously this database can be updated with some AI/ML model to get the idea that who are the top celebrities or who are the person whom I interact the most. And based on that, it can simply generate the top follower accordingly. And here, if you look carefully with this introduction of the cache over here, we have optimized our entire system a bit more. That is, right now, both this Fanout service as well as the backfilling service is not interacting with this follower database. Rather, what it does is simply have to fetch all the top followers from this Redis cache. And thus here to generate a feed in the near real time, here we are just making two calls and both are nothing but two cache. One is the latest post cache and another is the top follower cache. And you can easily understand with this approach, generating the feeds on the near real time will be super quick, and this backfilling process can compute all these things in near real time. I hope this is clear that how everything will be working over here and how this feed will get generated for the user as a pre-computed thing, or it will be fetched in the near real time with the help of this backfilling process. I hope I have covered almost everything that we have gathered in the functional as well as in the non-functional requirement. And I hope you have thoroughly understood this video and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So see you in our next video where we will be solving another problem on our system designing interview. So see you on our next video. Thank you.